Hello everyone. So in this session I will be covering a problem that was asked in the Infosys SP and DSE role online assessment. So Infosys hires a lot of people for this particular roles and thousands of people apply for it and they give a very good package too. So this position is for specialist programmer SP or DSE, the digital specialist engineer. This is a recent question that was asked in the online assessment and I will discuss the question as well as the algorithm that I used to solve it, and it passed all the test cases, and I will explain each line briefly. So let's see what is the question is about. So I've rephrased the question a little bit just to avoid the copyright issues. Otherwise the question is same. If you get the same question, it will be very easy to identify and you can use this approach to solve it. So if you're given a string S and then you take any substring of it. So given any substring of this string, this, it is said to have entropy if it satisfies these two conditions. That is, the length has to be at least 2 and the frequency of most frequent character in the substring is strictly greater than half the length of the substring. So to give an example, what does this mean? Let's take a sample substring. Now this is a string. Now let's take a substring BC BB. So this is a substring of this, and if you see, the frequency of B is 3 and frequency of C is 1 and length of the substring is 4. So now what I do is, what is the maximum frequency? So in these two, if you see, the maximum frequency is one of the character B and the value is 3. So we need to check if 3 is greater than length by 2. We can do integer division here. That means we need to check 3 is greater than 2, which is true. So therefore this substring BCBB has entropy. So basically we can say any string has entropy if it is of length greater than equal to 2 and the max frequency is greater than length by 2. So this is what this second property means. The frequency of so this substring has entropy. So you can generate almost approximately n square substrings from this string by taking each pair of index I and j, and you can find out whether that substring has entropy or not by simply calculating the frequency map of each substring and then checking whether the highest frequency that occurs is greater than length by 2. Although that is little bit time consuming because just going over all the substrings and then calculating frequency map, but I will show you how we can actually optimize it. And now this question introduces one more definition, that a substring is dominant if it has entropy and it is of minimal length. So basically we are talking about dominant strings are those strings which have entropy and the length is minimal. So like this substring, if we see, the length is 4 here, BCBB. So this has entropy. Now let's see if we can find a smaller substring of length less than 4 which has entropy. So consider this substring of this BBB. This also has entropy because the max frequency count is 3, which is greater than 3 by 2. And let's see if we can find any substring of length 2. So if we have BB, if we take this particular two letters BB, and then if we say the max is frequency is 2, which is greater than length by 2, which is 1, which is true. So BB is the substring of minimal length that has entropy. So if we collect all substrings of minimal length that has entropy, this list is what is called a list of dominant substrings. So another small substring is RR. This also has entropy and this also has substring of length 2. So this is also a dominant string. So if I talk about dominant string, we can say RR is a dominant string, BB is a dominant string. And if we talk about entropy, which substring has entropy, then we can see that BBB has entropy, BB has entropy, BB has entropy, RR has entropy, and we can find some more substring from this. So basically first we need to calculate which substring has the entropy, and then we only look for those substrings which are of minimal length like these two, and from these dominant substrings we return the one that is lexicographically smaller. So here obviously this BB is smaller than RR because the letter B appears before R. So we can just simply return BB in this case. So this will be the output or the answer. So let's go over some more examples and the sample input that was provided in the question. So if you look at the definition of this, a substring is dominant if the substring has entropy and it is of minimal length among all such substrings, and return the lexicographically smallest dominant substring, or 0 if there is no dominant substring. So in case there are no dominant substring, then we just simply return this string 0. Now these are few sample cases. This is the input, this is the output, and let's go over why this input generates this output. So if you look at this particular substring, string CCD, it has a lot of substrings, and let's look at those substrings which have entropy. So CC has entropy, DD has entropy because 2 is greater than 2 by 2, which is 1, and then let's see which others will have entropy. What about string CCD? So if you look at CCD, the max frequency is 2, which is greater than 3 by 2, which is 1. So this also has entropy. Let's look at if CCDD. So this max frequency is 2, which is not greater than 4 by 2, which is equal to 2 by 2. So this is not a string having an entropy. Let's look at this one, DDE. So here the max frequency is 2 and length by 2 is 1, 2 is greater than 1, so this has entropy. But when we talk about dominant, we only look at the smaller one, CC and DD, that's all. And when we have to return the output, we only return the one that has the minimal order, or that is the smallest string, so which will be CC. That is why the output is CC in this case. Now actually when we are going over this example, this might give a clue that we do not need to actually consider all the substrings of the given strings to generate the output. We only need to actually generate the substrings of the smallest length, of the minimal length. So because in the end we are only going to consider the dominant substrings, which are the one which are having the minimal length. So what we can do is we can loop over all the substring of the given string S, but loop in the way such that initially we only look at the substring of length 2. Once we have exhausted the list of all substrings of length 2, then we will move on to the substrings of length 3, and then we will move on to the substrings of length 4. And at any time we encounter a substring that has an entropy. So like in this case we encounter a substring that has an entropy and this substring has length 2. We do not need to consider substrings of greater length because that is not required by the dominant substring. So we can stop our loop there. So once we encountered a substring, in this case for example of length 2, we do not need to scan over all the substrings of length 3, 4, 5 and so on. We can just stop and just simply calculate all the substrings of length 2 that has entropy, and that will be the list of our all dominant strings. Similarly, in some another example, maybe there is no substring of length 2, there is a substring of length 3, then we exhaust or calculate all the substrings of length 3 that have entropy, and that will give us the dominant substrings also. This way we can save a lot of time because we do not need to scan all the substring, because that will be an order n square operation, and calculating the frequency map is also a time consuming operation. So let's see how we can implement this. So these are some input and output. So if input is this, the output should be this. If the input is this, output should be this. I have just put them in the form of a test case. So if my code is correct, this all should return true. So in the current case, I have tested it and they all work fine. And I will just go over how I have implemented it. And so this is the main function. that is actually given, the function signature that was given to implement, and this is the string s and the length of the string s. For Java, if you're coding in Java, you don't need this n because you can calculate it from s. So I will just briefly explain what I have done. I have broken down it into two more functions. So one is this function called has entropy. So this function has entropy has the logic for these two lines. So basically I have modularized the code and broken it down into some logical components. So whatever the condition was mentioned here in plain English, I have converted it to code. So a substring, it has entropy if the length is at least 2 and the frequency is greater than length by 2. So exactly that I have copied here. Here you will see that I have not mentioned the condition that s is of length greater than 2. The reason is will be clear later, because if you see in line 59, I'm actually only looping over substring of length 2 and greater, so I don't need to check that here. So I can say that this assumes that s has length greater than equal to 2, because I will not be passing any string of length less than that. Now the main idea here is, now how do I calculate the maximum frequency? So to calculate the maximum frequency, I actually use this map, the hash map class, and I convert this string s to char array. I loop over each char array, and I use this map.put function. This map.get.default is used in case this key is not already present. If this key is not already present, then this function will return 0. And so this whole will return 1. That means this character was encountered first time. So whenever a character is encountered first time, the map will have that character as the key and the value as 1, because the count of that character is 1. So that is why I've used this map.getOurDefault function, because it shortens the code, and after the loop is done, this map will contain the frequency of each character. And I don't need to go over the map again to fetch the max value. I can simply initialize max to 0, and anytime an update is made, so each time a character is encountered, a value is incremented, and when a value is incremented, there is a possibility that this current value could be a max value. So I save the current max value and I compare that the current value is greater than max. If it's greater than max, then I update it. So this is just a shorter way to write it, and if it's not, then the max remains same. So I only update the map if the current value, only update the max if the current value or the frequency I've encountered is more than what I've seen till now. So this max after the loop ends will contain the max frequency value, and the map will contain for each character as key and the value as the number of times that key occurs in the map or in the string. And we don't need to use map after this, but we only need to use max, and we need to check if max is greater than s.length by 2. If that is true, that means the string has entropy, otherwise it falls. So this code is exactly a conversion of this plain line of text or logic, that if the string has entropy. Now comes the other part. We need to get the dominant substrings. Now if we look at this code is has become more readable because I have divided it into multiple readable functions. So if you see, what I am doing here is I'm getting the list of all dominant substrings. It's just like here, I am getting the list of all dominant substrings, and then I am just fetching the substring which is the smallest. And that's what I'm doing here. In case the list is empty, I return 0. This was part of the condition here in the question. It's 0 if you return this special substring in case there is nothing in the list. Otherwise, we need to return the smallest substring. Now, how do I, in the list that I have, the substrings may not be in any order. So I need to sort them. And Java provides this collection.sort function to sort these strings in ascending order. And the first element will be the one that will be the lexicographically smallest substring. And I can just simply call this get0 to fetch the first element. If you haven't used this sort function before, you can actually even check Java docs and see the definition of it. So this is the Java doc for this, and if you see, it sorts the specified list into ascending order according to the natural ordering of the elements. So by default, if you provide a list of integer, if you see, it's it is using a template variable t. So it accepts any kind of argument, whether it's a list of string, whether it's a list of integer or list of anything, and it sorts them by their natural ordering. So many of the things like integers, strings, characters, they all have a natural ordering. So you don't need to specify any type of comparator or implement any kind of comparison function for this. It automatically will sort the list, in our case list of strings, lexicographically in ascending order, and that's what we want. We wanted the lexicographical smallest, and smallest will be the first element of the list, and we can simply return the first element of the list. So now this function is clear, has entropy. This is simply the implementation of the definition of the entropy, and this function is also clear. That's what the question demands: get the list of dominant substring and get the smallest one and return that. Now how do we get the list of dominant substring? Now this is where we can do something little bit cleverer. Rather than actually going over all the substrings of S, which will take order n square time, and for each substring we also have to calculate this map. So this function is actually, if you see, called from inside this. So this, if we go over all the substrings, then it can take n cube time. That will be very slow. So what we can do is we can actually go over all the substrings of length 2, then length 3, then length 4. So that's what this loop is for. So for length is equal to 2, it will go to till s dot length. And so initially I explore all the substring of length 2. I will come to this condition what this means. So now I want to basically this loop, what it will do, it will explore all the substrings of the length as specified by this for loop. So in the first case, if the length is 2, what it will do, it will basically go from I is equal to 0 to I less than s dot length. So this I, consider it as the first index of the substring. So given any substring of the string S, there will be a starting index and there will be ending index. So suppose I is the starting index. In that case, the ending index, since we want the substring of length len, the ending index will be I plus len minus 1. So you can actually check this easily. So if you have a substring a, b, c, d, e, so if I want to take a substring from index 3 of length 2, then the substring will be, so this is 0, 1, 2, 3, d is, so I is equal to 3 points to d, and we want to take a substring of length 2, so it will be de. So if you see, the d is at index I and e is at index 4, which is equal to I plus ln minus 1, because if you see I is the index, which is the index 3, length is 2 and minus 1. This is 3 plus 2 minus 5, 4. So this is just a mathematical calculation to find the last starting and ending index of the substring that we are working on. Since the substring starts at the index I and it has length len, the substring must end on the index I plus ln minus 1. And for it to be valid substring, this condition must be satisfied, because this is the index of the last character in the substring, and the index must be less than s dot length, because the index ranges from 0 to s dot length minus 1. Now, so if this condition is satisfied, that means this is a valid substring that we are considering. Now, this is a simple function call. If this substring has entropy, then what I do, I add it to the dominant substring list. That's all. So this code here is same. There is nothing else. So in most of the programming language, since I specified two parameters, I and I plus len, it will actually generate a substring from I to I plus ln minus 1. The second parameter is exclusive and the first parameter is inclusive, and then I add this dominant substring. So now if I add a dominant substring to this list, then that substring will be the smallest. The way we are looping is, we are looping from the lowest length to the highest length. So the moment I get one substring, I don't need to actually calculate substrings of further lengths, because we are only interested in the minimal length substrings or minimal length strings that have entropy. So that is why if once we have and added any element to the dominant list, we don't need to actually scan for further strings of length more than that particular element. So if it's not empty, that means we have actually already calculated the strings that have entropy and that are of minimal length, and that's what is equal to the dominant strings. We can just break out of the loop and we can just return the dominant element. So that's the main idea behind minimizing the efficiency of this program. So you don't need to, if you encounter, like in this case, if you encounter a dominant string of length cc, so our this internal for loop will build this cc and dd list. It will not, and it will break there. It will not go on to generate this substrings of length 3 because we are only interested in the minimal length things. And the way we are generating the strings that are having entropy is by going from lesser length strings to a higher length string. So we can just stop there, and that will reduce time complexity a lot. And we can just return this, and the rest is simple. We can just sort this particular list and return the 0. So it's not very difficult. If you go over this particular question and go over what I have done, it's pretty easy. And especially if you break it into parts, like I have broken it into these parts, like get dominant substring has entropy method. So if you break it down into multiple functions, things becomes more easy and more readable, and it's also easy to find bugs in case there are any. And you can go over this question. There is a high chance that you may encounter it again, and I can show you again that the output for this. The algorithm is same. You can actually convert this logic into any language, Python, JavaScript, or anything else, or C, C++. It won't be much difficult. The main idea is this breaking of the functions that will make things easier. The next main idea is looping from the lesser length substrings to the higher length substrings and breaking whenever you have exhausted the minimal length dominant strings, so that you don't waste time looping over the other things. There is one more question that I will be covering in my upcoming video. So I will show the question. But the question is this was also asked in the same Infosys assessment, and you can go over this question and maybe try it yourself. I will try to upload a solution and explain it in a week or two. And these are both live questions that are recently asked, so it will be very good if you go over both of these questions. And apart from this, if you have any queries, you can always write in the comments in the YouTube box, or you can actually contact me on my Telegram ID @codeeducator. If you need any assistance in cracking any interviews or assessments, or in any way you want to improve your coding skills, you can just email me, WhatsApp me, Telegram me. The details are there also on my YouTube channel. So thanks a lot. Bye.